So welcome to day 2 of NixCon. Just a couple of very few short information announcements. As a reminder, so during we're gonna have lunch again, fortunately, and there are some people with special dietary needs. And just as a reminder, you will find your special dietary stuff on the table in the back. So make sure it's not on the big one where everyone else is grabbing food. It's in the back, right? But it's there too. Don't eat the special dietary stuff just because it looks nice, right? I'm sure it's nice, but keep to your own stuff, because otherwise some people would be sad, which would make me sad. Okay, what's next? Please put your empty coffee mugs not all over the place, because afterwards the people have to clean up. And so let's be helpful and put it all on the trolley that you can see over there. And if you can't see it, you can at least find it later on. Also, we've got swag left. So there are still plenty of T-shirts. It would be kind of sad again if there was a huge amount of T-shirts left. So yeah, make sure those are gone. Bring one for your wife or whatever, or your kids. I don't know. Yes. Is there anything else? No, I think there is nothing else, which means we can start in a minute with our first speaker, which is going to be Ricard. Okay, so while he's getting ready for, are we actually ready, Mr. Stream responsible person? Okay, there we go. The first speaker for today is Ricard, and he's gonna tell us about setting up a deployment system from scratch, and how to make use of NixOS modules even outside of NixOS. So take it away, enjoy everyone, and a warm round of applause for Ricard.
So, good morning. I'm Ricard, and I'm here to talk about the Nix module system and how you can use it for more than just configuring NixOS. So, short intro of me. I'm a freelancing developer and DevOps guy. I've been building stuff based on Nix professionally for the last 5 years or so. I run the company Immutable Solutions, and I'm proud to have sponsored every NixCon so far. So, during this talk, I want to show you the way I've used Nix modules to implement operations infrastructure for a client of mine. And the stuff I present today have gone through a few iterations since I first started about 2 years ago. And I still work for this client, and we keep using this in production, and we keep improving it. In the end, I think I've come up with a system with some pretty interesting properties, and that is what I hope I will be able to demonstrate today. I have no product to show you. This is not something that you can take and drop into your own projects, unfortunately. We have some parts, small parts of it, open and out on GitHub. Very poorly documented though. So it would make sense to open up more of it, but as always, it takes time and energy to do that. So what I hope you will take with you after my talk is that you can use the Nix module system for more things than configuring Nix OS. And that modular declarative configurations, be it using Nix modules or anything similar, is a very nice way of configuring deployments and probably lots of other stuff too. So these are some core principles, you might say, that I've had in the back of my mind when building deployment tools. So I want to be able to bootstrap from nothing, except maybe Nix and Git. I want to configure as much as possible in a declarative fashion. And there should be minimal differences between production, development, staging, and so on, configurations. And it's nice to have all ops-related tasks available in some kind of shell. So all of those things makes it easy for new recruits to get started with projects, and it makes it easy to make changes in places you're not that familiar with, and of course to try out new things and experiment. So when you say you implemented a deployment system based on Nix, one of the first questions is why didn't you use NixOps? And I think it's been brought up during a few talks yesterday. And there's some issues that I have had with it. So it's not declarative enough. You have this state file you have to manage in some way. And that's not really compatible with my bootstrap from nothing approach. It's not modular or extensible enough. You can extend it by using the Python APIs. You can write new backends and implement new functionality. But I had a much more sort of flexible extensibility in mind when I started working on my system, and I hope to be able to show that today. Also, my client is using the Google Cloud Platform, and when we started, the NixOps backend for that was not as mature today as it is today, and I think there's still things missing that we need. So I knew I had to implement some of the provisioning stuff anyway. Yeah, so now I'm going to jump directly to how production deployment might look like for one of my team. And this is simplified, of course, but the concepts are the same. And if you configured NixOS, you recognize this syntax, this format. We use the exact same kind of modules that NixOS does. So in the top, we import two other modules. One of the Hello World module defines the application we're deploying, and the Google Cloud Platform defines everything that is needed to provision and deploy an application on Google Cloud Platform. And depending on what modules you import, you get different configuration options available. So the greeting phrase option comes from the Hello World module, and the GCP settings comes from the Google Cloud Platform. And then we have base modules that define things that's used for all our deployments, like name and domain settings and environment settings. So what I wanted to show you is that we can have a very clean top-level deployment configuration. And of course, this is a silly application, and we don't configure much here. But the concept is the same. We can have things that make sense, that you can read and write, that make sense even if you don't have detailed knowledge about how everything is set up. And this is exactly how Nix OS works too. You can sort of hide details in lower level modules and have sort of a layered configuration. So here we have a staging setup for the same deployment, and I just wanted to show you that this is also deployed to Google Cloud, so the differences are very small here. And here we have a development setup. We still import the exact same application module, but now we use another backend, a development backend that we have, and we import an additional application module, the monitoring module, and this is actually the exact same module that we use in production. So so it sets up all servers needed for log aggregation, metric visualizations, alerting, and all that. And we deployed that to, in production, we deployed that to a dedicated deployment, and all the other deployments will send their monitoring data to that deployment. But during development, we don't want to send things off to a central aggregation point. So instead, we just bring in all of that infrastructure inside our development deployment. So the developer will get all those services locally on his computer. And that is very useful to make sure there's no deviations between development and production. And you can set up things like alerts, log queries, and everything, and try it out locally, and then just directly move things to production when you're satisfied. Okay, so I showed you 3 variants of the same application deployment, and it all looks very nice, but probably a bit abstract. So how do we use this? We have a script that is a thin wrapper around the Nix tools that will evaluate this top-level module and all the imported modules. And in the end, it will produce a deployment shell. And this deployment shell will give you all the commands needed to work on that particular deployment. So it includes commands for provisioning the cloud resources, deploying and activating the applications, performing maintenance tasks. So in a way, each deployment configuration will result in its own unique deployment tool with all the features that's needed for that particular deployment. And that is what what I meant with a more flexible extensibility than NixOps. So we can plug in new things, support for new cloud resources or cloud providers or anything by just implementing new Nix modules and drop them into our deployment. So I'm going to show you how this works in practice using this development configuration. So here we have our development deployment, and the top level configuration is exactly the same that I showed you on the slides. And we have our shell builder that will take this configuration and build a deployment shell and then enter that. So now we can see that we're inside the Hello World deployment shell. And we can start things off by running the provision command. And this will start up, since this is uses the development backend, it will start up systemd containers for all the servers that are defined in our configurations. And it will also configure DNS locally on my laptop here for the endpoints that we have defined in our applications. So now we can actually open up a web page and see our application running here. And we can change the config. We can change this greeting phrase. And then we reload the config, and this will actually rebuild the shell. And now we can run the deploy command, which in this case is a bit of a shortcut since we can reuse the existing systemd containers. So we will just, the deploy command will just activate the new configurations. And those errors are expected here. And we have the new greeting place deployed. And I can also show you that, for example, we have a Grafana installation here with some dashboards. Yeah, there won't be much data here. We can refresh this sometimes, maybe. And then we. Yeah, sure. Oh, so yeah, we can see we got six requests here now, and it's yeah. And this is yeah. So those dashboards are the same that will be deployed in production, and then we can experiment with setting those things up during deployment and have the actual exactly the same sort of chain of flow of metric data locally, so we know. Yeah. Okay. And finally, here's a test deployment for the same application. And now we import the test backend instead. And it behaves very similarly to the development backend. Actually, it uses systemd containers and brings the whole deployment up. But it does that inside a Nix build, so we can run this on Hydra, for example. And we can now add a test script to our configuration. And as you can see, inside this test script, we can use the complete deployment configuration. So we don't have to hard code a greeting phrase in this small test. So we can pick up the things we need from the configuration and write this general assertion in our test script. So as you've seen, depending on what modules we import to our deployment, we get things like different shell commands, different deployment tasks. We also define Hydra jobs in this way, so application can sort of plug in their tests and builds that they need, and it will they will appear in our Hydra instance. And the monitoring dashboards also depends on like what backend you use, what applications you use, and all of this you can also define in a top-level configuration if you want to. So if you need some specific command for a specific deployment, you can just add it to that deployment and get that available in your deployment shell. So this is the complete contents of the Hello World application module. So as you can see, we have more levels of modularity here. So the application module imports another HTTP endpoints module, and that it will take care of setting up Nginx, configuring request logging, metric collection, DNS setup, as you saw, and it can even handle load balancing and stuff like that. So in our application module, we just have to drop in a small piece of Nginx config. And in normal case, you would probably proxy that request off to some real application, but here our complete application implementation is inside Nginx. So this way, as an operations team, we can sort of define a suitable abstraction for the applications developers. And this is one of the strengths of the Nix module system, that you easily can define those abstractions that make sense in a specific context, but you can still allow for users to sort of drop down to lower levels and use stuff below your abstractions. So as I mentioned, the modules we are using are the exact same things as in NixOS. So there's good documentation on how to implement modules in the official NixOS manual. I'm going to say just a few words about how we evaluate configurations and build a deployment shell. So as an example, consider those two very simple modules. The customers module just define a customers option, which is a list of strings. And the my customers module import this module and sets the customer's configuration to ABC. So Nix modules are evaluated by using the eval modules defined in Nix packages. And we evaluate, we give this function takes a list of modules as argument, and it will compose those modules and everything they import and evaluate and produce a final configuration out of it. And we can simply ask Nix for the customer's attribute, and then we will get back ABC as expected. And for our shell builder, this is a simplified version of it, but the concept is the same. So we just evaluate the top-level configuration module, and then we ask for the bash rc build and launch a new bash shell with this. And so in the lower level modules, we have things for defining commands, and they will build up this bash rc file that will make those files, those commands available inside your shell. So after having showed you lots of nice and happy stuff in this talk, I just wanted to admit that the Nix module system is not perfect. So the main issues I have with it is that the namespace in Nix modules is global and everything is public. So any module you import can change the configuration or even option declarations of any other module in your composition. And this can get messy, and it would be nice with some additional level of control. Maybe Elko has something for managing that in his new configuration proposal too, I don't know. But some way of sort of typing the module interfaces more strictly or having private interfaces or something would be beneficial. And the evaluating modules is quite slow, and in our setup we make things worse by having to evaluate several NixOS configuration inside for each deployment. So that is also a bad thing, and our Hydra setup is sort of spending lots of time of just evaluating all of those configurations for the test builds. Finally, since the modules are evaluated in a recursive fashion, it's easy to get into a situation where you make a configuration depend on itself somewhere, and you get those infinite recursions. And it actually can be quite tricky to find out exactly what caused it, and the huge stack traces that Nix will provide is not always helpful because they can sort of they often point to library functions within Nix packages and do not reveal the issues. And then my method of debugging or fixing that is often just to remove stuff until the infinite recursions go away, and then add back one thing at a time. So that's not ideal. Yeah, that's all for me. Thank you for listening.
Alrighty, so, okay, I was about to say who has questions, and the first hand is already in the air, so here we go.
Hi, thanks for the talk. I see that the way you set this up basically does all the infrastructure, set up DNS, machines, everything. And as I'm sure you know, there is a tool around called Terraform that does most of this stuff. So what was for you a compelling reason to go and develop your solution with Nix rather than using Terraform?
Yeah, so Terraform would be a great backend to our system. I mean, it would be very useful to generate Terraform configuration from our configuration and use that to provision stuff. So that is absolutely, and we do use for the cloud resources, we do use Google's deployment manager, which is also a declarative way of specifying the resources. So we generate a description of the resource we want from our configuration. But it would make perfectly sense to use Terraform as also the backend. And you could probably use NixOps as a backend to something like this too, like generate NixOps configuration to make use of provisioning code. Yeah.
More questions? Yes.
What does the dev backend look like in the code?
Yeah, so we have implemented this small daemon for running multiple NixOS containers, basically. So the dev backend will basically just generate basically just a map of machine names to NixOS configurations, and hand this description to our daemon, and it will bring up those NixOS containers and keep them running until one of them stops or something like that. So we use that daemon both for development and in our test scripts. So Hydra will actually, we do sort of impure Hydra builds where it will make use of the local NixOS containers daemon thing that we have. So the dev backend is actually quite simple. It will just build that description and fire it up.
More questions? Yes, Shay.
Hey, so we've talked about this a little bit. One of the issues I've run into with the module system is the global nature makes it very hard to reuse one module in multiple places because there's only one namespace. Have you run into that, or what do you do when you...
We haven't had any big issues with this, but that is mainly because we as a team and as a company can sort of control our modules, so we don't have to share them with sort of the public, or we don't use modules provided by someone else. But it would definitely be nice to have better control in this area, so that we would allow some sort of libraries of modules and stuff like that. But because that's entirely, you have to sort of just come up with some convention now and hope that people adhere to it. And yeah.
Yes, coming.
Does this setup require me running NixOS, or can this be used on a different Linux distribution? And do I need privileges for running this kind of setup, or can I run it as an unprivileged user?
So I think that you only need Nix, a working Nix installation to run this. But I haven't actually tried it on anything non-NixOS. And we have sort of a deployment machine that our developers log into and run their deployment shells from when they do production deployments and so on. But I do deployments from my local computer since I have an NixOS, so everything's set up. And the small daemon that I was talking about that brings up systemd containers needs to run as root on your computer, but you can then communicate it over a small over a homegrown protocol.
Do we have one more question? Nope. Alrighty. Okay, so then thank you very much for your interesting talk, Ricard. And I foolishly forgot to mention that Ricard is also sponsoring, or his company, Mutual Solutions, is actually sponsoring NixCon. So when I ask you for a warm thank you and applause, I expect at least 5 additional claps per person extra. So thank you very much, Ricard. Next up is Daniel Marlowe. Oh yeah, and time is up. I'm sorry, I was confused with names because you are
Plugin, is there a VGA?
probably want to have the mic in your hand because otherwise it tends to just be not loud enough, right? Yeah, yeah. You know, if you have as soon as you have the demo, just plug it in the stand. That's going to be fine. But otherwise, you probably want to have. I'll give you the mic after I introduce it, right? Okay, everyone, time for the next talk. Yay! You see, you're gonna get 2 rounds of applause. Okay, so next up is Richard, and Richard is gonna talk about his project called VPS Admin OS, and it's a lightweight hypervisor for Linux systems based on NixOS, and I'm looking forward to hear about it. So another round of applause for Richard.
Okay. Thank you very much. Welcome to my talk. So my name is Richard. I'll need to use another keyboard. So a few words about me. I'm an open source software and hardware hacker. You can find me on GitHub, or some of you might know me as SRK on IRC. So this talk is related to our non-profit organization called VPS3. So we are based in Czech Republic. We offer virtual private servers for our members. We started with OpenVZ in 2009, and you can find the site of the organization on vps3.org. So currently we have 1,300 members. We are running nearly 1,900 containers. Typically these are 8 cores, 4 gigs of memory and 120 gigs of disk space. You can work with that if you need more. Basically, this is hosted on much larger machines with like almost half tera of RAM currently, and we host all these containers only on 22 servers plus +2 storage nodes. So, what's the deal about OpenVZ? OpenVZ is problematic for us. We are running OpenVZ 6, which is going to be abandoned very soon. VZCTL is already abandoned, which is a tool to basically configure containers from user space. Also, kernel is going to reach L quite soon. The kernel is 2.6 point something, very old. And OpenVZ 7 is also problematic for us because there is no process transparency. It's not like OpenVZ 6 anymore, like it's not a community. There are no sources. It's based on top of RHEL 7. And we don't want that. So another issues we're starting hitting with this old kernel is that, for example, some distributions started to be problematic to upgrade because of some system dehardening, for example. We had to remove, for example, system core filter or memory deniv write execute from some memory services, so the distributions still can boot and work again. Also, NixOS on our production nodes is also stuck on 1709. That's also because of systemd and I think UDEV as well. Cool thing, while we were debugging this, I realized that with NixOS you can actually git bisect a live running container, a live running system, which is like, wow, crazy. And I've actually managed to find the commit. Sometimes you hit the commits that are not buildable, but which is quite rare. And I didn't do that automatically, but you can like mark the revision manually, and you arrive at the commit which actually breaks everything. So we started searching for replacements. Our requirements are full VM look and feel. Like our containers are not like containers with only one process, but we are running a full system in it. So, for example, it boots as a PIT1, it boots full systemd and all the services inside. So we also need a reliable isolation due to security, so other people don't see other people's stuff. They shouldn't see. Also, they shouldn't be able to do anything to hosts. We also need a resource isolation to apply some limits, for example, CPU or networking limits if you are overdoing something. Also, we need powerful storage. We are a ZFS house. We are very happy with that. And an easy administration. So, for mainline Linux, user namespace is a must for us. What it does is basically it remaps your PID1 in a container to some other PID which is not PID1 on a host system. And we also apply some additional protection layers. There you can choose with LXC, I'll get to that. You can choose between AppArmor and SL Linux. SL Linux is quite problematic because you need the policies for that. And there is only few reference policies. I think that's RHEL and Fedora. And I think Gentoo has some policy. With AppArmor, that situation is quite easier, so we chose that. And we also run seccomp on with LXC as well to limit some syscalls. So we use LXC. LXC is quite bare bones. It knows how to start the container, but you need to configure all the stuff manually. Basically, you need to set user mappings. You need to manage networkings. You need to manage C groups. It's quite hard to manage by hand. So, also powerful storage. As I said, we are ZFS Zoll house, and we use it because it's like most IOPS reducing solution. We don't like to lose data. We have backups, but you know, with ZFS, situation is much better. Also, with new ZFS, there's support for native encryption, and we use send and receive for backups heavily. So, easy administration. Currently, our systems are managed with Salt. There are these, that's basically CentOS 6 nodes running OpenVZ. We decided that we want to go some more pure way. I think, I don't remember the right word, it's like the congruent configuration management, where we basically don't have a local state on the machines. We build the live images. We don't have any surprises. We want, what's running is basically what's written in the Git repository. So we were looking for some solid foundation to build upon, and you probably know where this is heading. So VPS admin OS means NixOS. Sorry for the colors of the logo. I will skip that. I made this. We can build our own software. We don't need large companies to do that for us. Thanks to Nix and Nixos and all of you. So we also not quite based the system on Nixos. Well, it's also based on Nixos and also based on NotOS. Thanks to Clever, I didn't have the chance to meet you already. So thank you very much for your support, for examples of like how to make your own OS on top of Nix packages. So we basically use, when people ask about relations to Nixos, NotOS, and VPS admin OS, I tell them that the Nix package is basically one huge repository of packages, and a small part of that is actual Nixos and operating system. So NotOS actually uses that as well. As I said, was made by Clever. Apart from the small run-it-based system that compiles down to 50 megabytes COSH image, it also supports net booting from iPXE, actually signed iPXE, which is quite nice. And Clever has some examples which you can actually use to deploy your own netboot server with all the images. So, VPS admin OS is quite similar to NotOS. We also run it. We use mainline Linux. We use LXC, LXCFS, and Zoll, also AppArmor. Critical thing for us was that we need to be able to alter any component easily, quickly patch some stuff. We already have some patches on top of kernel, on top of LXCFS, and also on top of ZFS. Currently, each node has basically image built from a single NixOps repository. This is deployed to one netboot server, which hosts all the images for every node. We also support ISO images, so you can also boot from any of the other media if you don't want to run the full-fledged like deployment. Yeah, and we use NixOps, assuming full control. We had some issues. I'm actually quite a heavy user of NixOps now. We have some patches. There are mostly collected community patches. For example, there's a patch that we can mix two versions of NixBug, so we can basically deploy machines. We can deploy Nixos machines, and we can also deploy VPS admin OS machines from one repository. And let's go. The most important part is the management utility written by our colleague Aiter, which is very powerful. It manages all the stuff you actually need for running containers. Mainly user namespace support, control group management, content management itself. You can manage devices. For example, you can add KVM or tab devices, or I don't know what else. Also, recently we added AppArmor profile generation and management, so we can have different AppArmor profiles depending on what you run inside your container. This is quite important. For example, yeah, I missed that. Some people were asking about Docker, or for example, Docker is quite hard to run on this old kernel, on OpenVZ6. So people were running it in KVM basically. So you have a container, you start a QEMU or KVM inside, and there you can do whatever you want, because if you need new kernel, there's like no other option. So OS also can do network management. We have two types of network configurations: simple bridge networking and routing networking. It also handles migrations. So if you have older configuration of your containers, it can during update it can update and migrate these configurations. Because we need to be able to run the machines, for example, for like half a year without the reboot. We also provide template repositories, and some others. I will show this in demo. Okay. So quick start, for example, when you boot the OS, the very quick way to actually get the container is to run these few commands. I will probably leave this as an exercise for reader. The first command basically initializes your ZFS pool. Then you need to create a user. This mapping means that the user and group ID is mapped to ID 5000. No, I think I'm confusing that. That's no, the actual user, I think that his IDs are 5000, and they are actually offsetted by the 666,000 offset, which means that if you look at the container from the host side, you will see that its bits start at 666,000, but from the inside you have bit 1, you still have bit 1. So, and when you have your user, you can start the container, for example, unstable Nixos. And what's missing is you want probably configure networking. The simplest way is to use the provided bridge with tab alexcbr0 by default. This runs DHCP, so by running this simple ctnet if new bridge command, I missed one important thing. You don't have to repeat the osctl over and over again. You can like skip it and call subcommands without that over and over again. I recently added tab completion, so this is also quite pleasant to use. And also there's a way to configure routed networking, which we actually used in production to be able to assign like public addresses, public IPv4s to containers. So what's cool as well is that we can do nesting with LXC, so we can run containers in containers in containers. Or, for example, we can run KVM, even full libvirt inside containers. So there's basically endless possibilities of what can you do. There's also an example how to basically pass a device to a container. In this example, you just pass the dev KVM, and after that, you can run either libvirt or QEMU with KVM support. So, in the OS, like some few batteries included, I call them. For example, rsyslog and TCP forwarding use Greylog to collect these logs. This is quite nice because after the machine boot, you have the full log of the boot as well on this one central site. We also use Node Exporter and Prometheus and Grafana. Bird for routing, NFS for to be able to mount network attached storage and also restore backups. Cronid for time, and also, of course, Nix and Nix daemon. That's also quite useful because when you have like a node and you need to log into that and you find that some piece of software is missing, you can just enter Nix shell, and after you quit the shell, you can just collect garbage, and the system is like before. And there's no craft left over. So, this is all nice, but we would like to migrate the whole cluster, and we need some nodes that will actually have some persistence because we can rely, like chicken egg problem, you can netboot when you don't have a netboot. So our storage nodes will actually be installed. We actually recycled quite large parts of Nixos generate config and Nixos install. It's like a bit generic. It's actually quite interesting that you can take these things and they just work with really small changes. So you can now optionally install this to disk. And also, as I said, we need to be able to update the machines, not only reboot them, because the people, if there are like 100 containers running on them and you have like 15 minutes of downtime, that's not what you want to do. So we implemented our own switch to configuration. Not sure which one is it, if it's activation script or switch to configuration, but this thing also handles restarting runit services or reloading runit services, and most importantly, it reloads LXCFS, which can be like reloaded with some signal, and will load its new library without actually destroying all your LXCFS mounted procs file systems. Yep. Also, if you have the machine installed, you can manage it just like Nixos, and the generic tool is OS rebuild, which is quite similar to Nixos rebuild. Also, we have our own version of declarative containers. These are different to Nixos declarative containers that they are imported by the OSCTL daemon on boot. Actually, syntax is quite like similar. You can actually define a user as well, which the container is running under. And how it works, actually the images are part of the image that the machine boots, and on boot they are actually copied to ZFS pools and started if you configure that as well. So yeah. Well, I want to say that it's different to nspawn, basically, to Nixos declarative containers, that it's not shared with the host, but there's also a way to update all the containers with Nix machinery, and so if you boot a new version and you want to update your containers, you can do that, but they are persisted on ZFS pools, so you can have backups of these. I actually wanted this feature mainly for testing, so I don't have to like start the containers over and over again manually while I'm testing stuff. So this is quite handy. I just have few containers defined, and when I run the VPS admin OS, they are always there. So you can try it quite easily. Make QEMU is just a wrapper for Nix build. I will show you just in a moment. We actually have our own fork of Nix packages, but that currently contains one cosmetic patch which adds Ruby man pages, basically. There were like 5 patches on top of Nix PKG, so most of them are upstream now. I wish we get rid of this last patch, so you can build with upstream Nix packages as well. So, and some links. There's very nice documentation on vpsadmin.os.org. You can find all these little things, how to set up your machine, how to install, how to manage containers. You can check out our repository. Actual OS is under the O/OS, I'll show that as well. And you can talk to us on NixOS channels or vpsadmin.os channels. And also, recently I've also added ISO images to, these are also built with the netboot images for nodes. So basically there's one repository that builds a public-facing website and all the required node images for a cluster. So to sum it up, in production currently we have CentOS 6 with this old kernel, and the environment we currently call staging is vpsadmin.os with Linux 4.18.12. We call it staging, but we currently treat it like production, and I think that the next year we'll start migrating quite heavily. Actually, the missing feature is that we actually don't use OSCTL to create containers. You have a full-fledged admin panel for that, and that's kind of future work, basically, to be able to deploy that as well. So it basically talks to a daemon, and when user uses a web interface, you can create this new container, define all the properties, networking, like you are used to with other cloud providers. And missing feature is actually the cloning between the old environment to the new one, which is going to be probably troublesome. But since these are only root.fs images, it should be quite doable. So, also, I mentioned this already, our old cluster was managed by Salt. Salt, I don't know. I feel like it's like Ansible with templating. I think that too. No comment. We actually use NixOps and Node Exporter and Prometheus. There's one missing thing I don't like about this metrics-based monitoring system is that they scrape the machine periodically, but there is no way to get actual live metrics to your laptop and to be able to see the cluster state in an instant. So, a little demo. Find the correct workspace. My window manager. Haha. This is interesting. And the presentation on 2 workspaces simultaneously. Never mind. So I won't show you how to actually start. No, I will show it. Then yeah, I'll try because I have to use like external keyboard, and also this thing. Impress is trolling me now quite heavily. No. Oh, yeah, there we go. Okay, so this is the repository. It actually is like kind of monorepo. It contains all the utilities. In OS subfolder, there's actually OS. Yep. And also OSCTL, which is a command line tooling which talks to OSCTLD. These things are written in Ruby. We are heavy users of Bandix as well. There are some tooling. Basically, our makefile only wraps Nix or Bandix. No, this is not quite. Yeah, and so we also have a SVCTL tool, which was added recently for managing run levels. And let's go to the OS subfolder. It's quite similar to not OS. We've added a bunch of modules. We reused a bunch of modules from Nixos. For example, we need getties, we need PAM, for example, and all these batteries include stuff I mentioned. So let's just run it. You can just use make QEMU, which is another Nix build wrapper. Yeah, you can see it quite well. And after it resolves all the stuff, we'll boot in a moment. Yeah, so you can see it boot now. It will auto login you. So we tried to make it easy for people to actually just run make QEMU and get the running system to be able to hack on it. Right. So I will SSH into it because of the QEMU terminal is quite bad. Huh. If I know, maybe I didn't set the password. Never mind. Stuff's trolling me today. Never mind, I will use this. So I have two declarative containers that were defined in a configuration. I'll show you how that actually looks. We have some impurity called config local nix, which is loaded with your custom configuration. As you can see, it imports few containers, which one is called simple and one is called web server. So I don't have to create any. There's actually this instruction I was showing you is as part of MOTD. So you can just copy paste these. But yeah, you can see that we have a running web server and some simple container. Both these are Nixos 1809. Yeah, I will switch to some more, so to our dev node, which there is some more stuff running. You can see that we can run basically any distribution. We try to support these most popular distributions, and especially Nixos. That's my job. And what I want to show you is, like, for example, you can enter the containers. Let's see, Nixos. Yeah. Yeah, this one is not running. Let's find some running. ICT. All two. Yeah. What's this actually? I didn't notice. That's Alpine actually. Yeah. So what I wanted to show you, we actually use Hydra as well to build this, but the thing is that we cannot easily test it with Nixos infrastructure because it's heavily dependent on, for example, wait for some systemd unit tooling. And one interesting thing is that we actually developed this for a few months without any hardware. We've just used QEMU, and the QEMU is just too good for some reason. And when you actually test stuff on real hardware, stuff breaks. And there are some race collision, there are some corner cases. So what I'm trying to do is like to create some like a virtual laboratory where you have machines. I actually have this dev node is connected via USB to serial to UART to another machine, which runs like some, I won't go into details, TCP to serial bridge. So I can just use this comport remotely, and that's not all. I can run an automation tooling for that. This is a prototype, quite heavy prototype, which will actually use NixOps to deploy our development configuration, and then it will actually cycle the node. It will write the reboot to the console, and then it will do the expect on the whole boot, basically. I think I could demo this as well. We have like 1 minute. I'm not sure if that's with question or not. Yeah, I will just run this. I hope it's not gonna build squash FS images again. But and one last thing. Yeah, this now it's running NixOps. After it's done, it will switch to the second part, which is actual interaction with the machine. Yeah, it will take some time, but I will show you another thing. Meanwhile, yeah, no, don't mind the name. Naming problem is quite hard, but the point is that this is able to scrape the metrics from Prometheus. It's another proof of concept. I want to get the feed of the metrics like live, and I want to script the monitoring, not rely on some pre-made tools, basically. So this is live. This is actually over HTTP currently, but I want to use another backend for that, which I've developed. It's called ZRE. And some of you might know it. Yeah. So that's pretty much it. I will leave this running so you can see how it works and how it reboots. Yeah, so ZRE allows me basically to deploy software on various nodes, and they will. Yeah. Yeah, I think it's finished actually. Yep. Thank you.
Yes, and thank you indeed. And who has got questions? Nope. Yes. Huh.
Hi, very interesting stuff. So you told that you were generating iPixie image and booting the servers essentially just over the net in an immutable mode.
Yep.
But after that, you told us about partitioning the disk and installing the OS on servers anyway.
Yeah.
So what is the advantage of installing when you're told about that the real advantage is about not installing?
I mean, it's to solve this chicken egg problem, because if you have a cluster, like you need some machine which actually hosts the netboot server, you know. But you can use live images. You can actually plug on some USB stick to do that for you, and that's quite that's why we like want to have like installation. So we can install the OS on 2 storage nodes, for example, and that will host the netboot images for the rest of the cluster.
Any further questions? Do we have questions from the internet? I love saying that. No? Okay. So thank you, Richard, very much for an interesting talk.
Thank you, too.
So, which means that for the next 30 minutes, you can again